So next we are going to see cell concept. So what is a cell? A cell is a line processing for any manufacturing of parts placed in a sequence of operation to complete all the process to form a final part and ready to ship to the customer. That means, say example, we have a product. So there will be many operation to the product like operation 1, 2, 3, 4. So all these operations are placed in a sequence and in order to get the higher production rate. So the cycle time shall be balanced to run in a cell. That means once the first operation completes, immediately that will be given to the process 2, then 3, then 4, then after 4 the final part will come out. So in order to run in a cell, we shall balance the cycle time. Right? Let us see an example. In the below example, the first operation is milling, where it takes around 5 seconds. And the second operation is reaming, and it takes 5 seconds. So then there is a plug gauge inspection that takes again 5 seconds. Then after that they'll do visual inspection like any defect is there or not. That takes 10 seconds. Now if you observe this process, now for each part he takes 5 seconds. He is also taking 5 seconds. He is also taking 5 seconds. So now if you see visual inspection is 10 seconds, that means only from here the final part will come out. So the visual inspection takes more time. That means he will be free for 5 seconds. Here continually operations will be happening because all the three operation cycle time is same. But whereas when we come to the visual inspection, each part it takes 10 seconds. Therefore here the WIP work in progress will be more for the visual inspection fellow. So how to balance this type of cell? Let us see how to balance. So what they have done, milling is 5 seconds, reaming, plug gauge inspection is 5 seconds. Now they have made two lines, two separate stations, not separate stations. They added one more visual inspection so that what happens, the load will be uniformly distributed for both of them. That means every 5 second one part will come, so it will be distributed to both of them. Therefore, the line is balanced and every 5 second we will get one OK part. One OK part. This is an example of cell balancing. Now let us see an common example. Before this was a process. The operation one happens here and batch with a batch methodology they were moving to the next station. From 2 again it was going to 3, from 3 again it was going to 4. Now if you see this type of batch process, the machines are placed in elsewhere, and by doing batch, one particular batch they are moving the item. So what happens, the output will come late, as well as the movement is more. What is the improvised process in a cell? Once we apply the cell concept, now if you see, they arrange a sequence of operation in a U-shaped cell. What happens, once the material is in here, it will follow all the operations and it will come out. So we will get the output instantly, as well as if any problem happens between the stations, we will understand and correct the process. So this is an example of cell processing. Now let us see just-in-time manufacturing. So what is just-in-time manufacturing? The first one is producing output as per the customer need at any target given at any instant time. That means, say every month 10K is the customer requirement. Suddenly customer asks we want 30K, 30,000 parts, 30,000 products. So what is just in time manufacturing says is, at any given target we have the resources to to shoot the customer requirement. So that is what they are telling in the point one. Producing output as per the customer need at any target given at any instant of time. And the second one, what we do, we calculate the tag time. We'll calculate tag time, what tag time really customer wants. Based on that, we will add resources internally. So we're going to add resources and balance it. So this is called, by balancing and adding resources, what we'll do, we will satisfy the customer need at any instant time, whatever the target they're going to give, because ultimately they're customers and we need to satisfy them. So this is called just-in-time manufacturing. So the next chapter will be basic Six Sigma concepts, standard deviation, the Pareto principle, voice of the customer, and basic metrics. This one we'll discuss in the next video.